Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. Session 2, Secular Trend. In this session, we are going to talk about secular trend in detail. Secular trend is one of the component of time series. Calculating secular trend by freehand or graphical method is studied in the previous session. Also, the components of time series, economic time series have been dealt in the previous session. In this session, some more illustrations will be done to calculate a secular trend by the method of semi-averages and method of least squares. First of all, method of semi-averages. When this method is used, the given data is divided into 2 parts, that is what is called as semi-averages. After the data has been divided into 2 parts, for each part the average is calculated. We shall see an example. One example has been already worked out for calculating the trend line by freehand method. So, this is second example wherein we fit a trend line by the method of semi-averages. Fit a trend line in the sense calculating trend values by the method of semi-averages. First of all, the year has been given from 2004 to 2010. Sales of firm A are given as 102 in the year 2004, 105 for 2005, 114 for 2006, 110 for 2007, 108 for 2008, 116 for 2009 and 112 for 2010. For this data, we have to calculate trend line or trend values by the method of semi-averages. The solution goes like that. Since 7 years, that is from 2004 to 2010, there are 7 years are given, the middle year shall be omitted and an average of the first 3 years and the last 3 years shall be obtained. That is 2004, 2005, 2006 is the first 3 years. So, we calculate the average for the first 3 years and last 3 years are 2008, 2009 and 2010. So, the average for the last 3 years are also calculated. Since the number of years is 7, which is odd, the whole data cannot be divided into 2 equal parts. So, we have to take the first 3 years as one part and the middle year as another part and the last 3 years as the third part. Like this it is calculated. First of all, the average of the first 3 years is 102 plus 105 plus 114. 3 values are taken into account, therefore, divided by 3 is equal to 321 by 3 is 107. And the average of the last 3 years, leaving the middle value for corresponding to the year 2007, the last 3 years is calculated for 2008, 2009 and 2010 values are 108 plus 116 plus 112. 3 values are taken, therefore, divided by 3 is 336 by 3 is equal to 112. Thus, we get 2 points 107 and 112 which shall be plotted corresponding to the respective middle years. That is, respective middle years corresponding to the first 3 years is 2005 and the last 3 years middle year is 2009. Okay. So, it is written like the average of the first 3 years is calculated as 107 and it is written here against 2005. This is semi-averages. Okay. This is 2005 is the middle year of the first 3 years, and corresponding to 2007 I shall write 1110 as it is. And for the last 3 years we calculate the average as 112, and it is written here against 2009, which is the middle year of the last 3 years. By joining these 2 points we shall obtain the required trend line. The line can be extended and can be used either for prediction or for determining the intermediate values. That is for prediction, in the sense we can also calculate the y value, that is sales of firm A after 2010 year, and also we can calculate the trend values for the intermediate years. If anything is left out, we can also find out the trend values for the intermediate values. Now, this illustration given was for 7 years. 7 is an odd number. Now, when there are even number of years like 6 years, that is 6 different years are given, or 8 different years are given, etc., 2 equal parts can easily be formed and an average of each part is obtained. However, when the average is to be concerned, there would be some problem in the case the number of years is 8 or 12, etc., because when the number of years is 8, you will divide the number of years as first 4 years and the last 4 years. That average of the first 4 years calculated should be written in between the middle of second and third year, because for the first 4 years there is no middle point, isn't it? Therefore, the average of the first 4 years has to be written in the middle of second and third year. Similarly, for the last 4 years, the average should be written in between the 6th year and 7th year. Okay. For example, if the data relate to 2005 to 2010, just count how many years: 2005, 2006, 2007, 2008, 9, 10, which would be the middle year. In such a case, the average will be centered corresponding to 1st July. The middle year is between 2007 and 2010. So, 1st July 2007, that is middle of 2007 to 2008. For example, I just write here 2005 okay. There are 6 number of years, so the average will be whatever the averages you are calculated, that will be written in the middle of 2007 to 2008. That is middle year of between 2007 to 2008 is after 6 months completed, because there are 12 months in the year. After 6 months completed, that is after 30th June, the 1st July 2007 is considered as the middle of 2007 to 2008. Next method is method of least squares for computing the trend values. After the trend values are calculated, trend line is drawn in the graph. This method is most widely used in practice. When this method is applied, a trend line is fitted to the data in such a manner that following 2 conditions are satisfied. That is, the first condition is summation y minus yc. Yc in the sense computed y, just y are the original data given in the question. So, the difference between the original data and the computed data, when you take the summation of those values, it should be equal to 0. That is, sum of the deviations of the actual values of y and computed values of y should be 0. The second condition is again the sum of the deviations of the original and the computed values, square values is should be least. That is why it is called as method of least squares. The squares should be least. So, the sum of the squares of the deviations of the actual and computed values is least from the original line. That is why this method is called method of least square. The line obtained by this method is known as the line of best fit. The method of least squares can be used either to fit a straight line trend or a parabolic trend. Straight line trend in the sense it will be a linear trend, and parabolic trend it is a non-linear trend. The straight line trend is represented by the equation first of all for computing the y values. Yc is equal to a plus bx, where we have to find out this a value and b value by the following formula, where yc denote the trend computed values to distinguish them from the actual y values. A is the y intercept or the value of the y variable when x is equal to 0. B represents the slope of the line or the amount of change in y variable that is associated with the change of 1 unit in x variable. So, A represent the value of y when x is equal to 0 and B represents the slope or it is a change in y variable associated with 1 unit of change in x variable. The x variable in time series analysis always represents time in the sense year or minutes or hours, like that. So, whatever be the unit of time, that should be converted to values so that we get summation x is equal to 0. So, we usually will take the middle year or middle point of the x values and subtract it with the original x values, so that we get the deviated points of x, and so that we get summation x is equal to 0. In order to determine the value of the constants a and b, the following two normal equations are to be solved. The two normal equations are given by summation y is equal to n a plus b into summation x and summation x y is equal to a into summation x plus b into summation x square, when n represents number of years or months or any other time period for which data are given. Actually, these two equations are calculated using the formula of the normal equation or the straight line trend equation a plus bx. You have first of all you take the summation as it is. So, summation y is equal to summation a plus summation bx. Summation a is nothing but n into a, because a is constant, n times it is added, and plus b into summation x. We get the first equation. Okay. Now, take the original equation, multiply it with x. Okay. Multiply it with x, it becomes xy is equal to a into x plus b into x square. Now, take summation, summation xy is equal to a into summation x plus b into summation x square, which is this line. We get the first one like this and second one by multiplying with x on both sides and then taking summation. Okay. Suppose if we have to calculate the three constants a, b and c, for the next we will be studying that. That is called fitting a second degree parabola. This is fitting a straight line, right. Therefore, only two constants a and b has to be found. When we have to find out three constants a, b, c, one more time you have to multiply with x and then take summation. We will get three equations. Three equations are solved to find three constants a, b and c. It should be noted that the first equation is nearly the summation of the given function and the second is the summation of x, as I told you, multiplied by the given function. X is being multiplied with the equation, given equation, and then summation is taken. We can measure the variable x from any point in time in origin, such as the first year. Origin is taken middle value of the years, but the calculations are very much simplified when the midpoint in time is taken as the origin. That is what the origin is, the midpoint of the years, because in that case the negative values in the first half of the series balance out the positive values in the second half, so that summation x is equal to 0. You have to take any one year as the origin among the x values. Usually the middle of the years is taken, so that when you subtract the original years with the origin, we get half of the values as negative and half of the values as positive. so that when you add the negative values and positive values, we get summation x is equal to 0. In other words, the time variable is measured as a deviation from its mean. Since summation x is equal to 0, the above two normal would take the form, because when x is equal to 0, we get summation x is equal to 0 in the sense we will have only summation y is equal to n a, and summation x y is equal to, this will become 0, summation x y is equal to b into summation x square. So, when we find summation y, we will get a just by dividing with n, and the next part this is not available. Therefore, when summation x y and summation x square are found, then we can calculate b as summation x y by summation x square. So, summation y is equal to n into a, so that a is equal to summation y by n. Summation x y is equal to b into summation x square. Therefore, b is equal to summation x y by summation x square. The values of a and b can now be easily determined. That is what is given here. Summation y by n gives y bar, and summation x y is equal to b into summation x square. So, b is equal to summation x y by summation x square. The constant a gives the arithmetic mean of y, and the constant b indicates the rate of change. It should be noted that in case of odd number of years, when the deviations are taken from the middle year, summation x would always be 0 if the x origin is placed midway between two middle years. Hence, both in odd as well as in even number of years, we can use the simple procedure of determining the values of the constant a and b. After working out an example in freehand method, first illustration and second illustration for computing the trend values by method of semi averages, next illustration is computing the trend values by method of least squares. Below are given the figures of production in metric tons of a sugar factory. Years are given from 2004 to 2010, and production in metric tons is 80 metric tons for the year 2004 and 90 for the year 2005. Similarly, 92, 83, 94, 99 and 92 for the corresponding years from 2006 to 2010 respectively. The question is fit a straight line trend to these figures. Plot these figures on a graph and show the trend line. Estimate the likely sales of the company during the year 2012, because the values are given up to 2010 only, and we can predict the future based on the trend values. That is, we have to estimate the y value, that is likely sales of the company during the year 2012, which is the future year for the given data. Okay, the solution goes like this. Fitting the straight line trend, year is from 2004 to 2010, and production in metric tons is given 80 to 92, and we calculate number of years as 7, and summation y is equal to 630. Deviations from middle year x is 2007 is taken as the middle year. Therefore, 2004 minus 2007 is minus 3, 2005 minus 2007 is minus 2, 2006 minus 2007 is minus 1, like that 0, 1, 2, 3. Now, you just add summation x is 0, and it is very easy to calculate a by just calculating summation y divided by n. Summation x y is multiplying x and y. 80 into 3 minus 240, 90 into 2 minus 180, minus 92, 0, 94, 198, 92 into 3 is 276. So, when you just add summation x y is equal to 56, then we calculate x square, because summation x square is also required. Summation x square is 941 and 0149. Okay, how shall we calculate these trend values? First of all, for fitting the trend line, a and b has to be found out. Since here summation x is equal to 0, a is equal to this formula of a and b to be used only when summation x is equal to 0, summation y by n, and b is equal to summation x y by summation x square. Okay. A is summation y. What is summation y? 630, and 7 is the number of years, okay, which is 630 divided by 7 is equal to 90, which implies A is equal to 90. Next, summation xy by summation x square, 56 by 28 is just nothing but 2. Now, therefore, straight line trend is y is equal to a plus bx, therefore, y is equal to 90 plus 2x. Okay, this is the trend equation. Using this trend equation, we have to calculate the trend values. 90 plus 2x, right? Here 90 plus 2 into minus 3, because x value is minus 3 here, y value is 90 plus 2x. Okay. So, 90 minus 6 is 84. Similarly, 90 plus 2 into minus 2 is 86, and 90 plus 2 into minus 1 is 88, and then 90 plus 2 into summation x is 0, and like that these are calculated, so that we get the summation yc is equal to 630. Next, we are also asked to plot these figures and fit the trend line, show the trend line. We have to draw the graph, plot the years 2004, and the values in between are brick, and then 75 is taken into account. The first value is taken as 75 after 0, where the whole graph is shrinked at this point, and therefore, these two lines are drawn to show that after 0, 75 is taken into account. Okay. This is a production, and these are years. Okay. For 2004, the actual value is 80, and the computed value is 84, 75, 80, 85, 90, 95, 100. Okay. So, corresponding to the first value, the actual data is 84. 80 is the actual value, and 84 is the trend line. 80 we should plot here, and 84 is somewhere here, that is plotted here. Okay. Like that the values are plotted corresponding to 2005. Corresponding to 2005, the value is 90, and the trend value is 86. Okay. Now, like this the points are drawn in bold for the actual data, or we shall use some colors, and for the trend line we shall use the dotted lines. Okay. This is dotted lines. 85, then 86, like that the values are calculated and the graph is drawn. The third question is, we have to calculate the likely sales during the academic year 2012. When year is equal to 2012, then x is equal to whatever the year minus 2007, isn't it? 2007 is the middle year. Therefore, year is 2007, year is 2012, given year minus 2007 is 5, x is equal to 5. Substitute this equation in trend line equation. A trend line equation is y is equal to 2x plus 90. Substitute for x, y is equal to 2 into 5 plus 90 is equal to 100. This is the value corresponding for 2012. So, the estimated sales of firm A in the year 2012 is 1000 metric tons. In this session, we talked about secular trend. An example is worked out in calculating secular trend values by method of semi averages and method of least squares. Based on the discussion in this session, the following example can be done. Apply the method of least squares to obtain the trend values from the following data. Years given are from 2006 to 2010. So, the year is 2006, 2007, 2008, 2009 and 2010. Next, sales in lakhs tons are given as 100, 120, 110, 140, 80. We have to find the trend values by the method of least squares. Thank you.